So just let me explain that this is interview for the Anti-Aging Journal. We have 8,000 audiences, reader, and I interviewed a very distinguished researchers every 2 months. The audience is the clinicians, so don't use a very basic research word.
Okay.
So I understand that there are several hypotheses in the aging, and your theory is the genome stability is the most important for the anti-aging, right? So would you please explain a little bit more about that?
So what we know about the role of genome stability is that we know that defects, all the proteroid syndromes that we know in humans, where aging occurs in a rapidly accelerated fashion, that the underlying mutations are linked to genome stability. So that's a very strong argument that genome instability is driving the aging process. What we now start to see in recent years is that so many different processes are responding to DNA damage. So the DNA is constantly damaged, that we know, in every single cell it's constantly damaged. But what we learn now is that the way cells respond to that is very consistent with all the aging phenotypes. So for example, it is believed that neurodegenerative diseases are caused by protein aggregations. Now what we find is that the DNA damage response burdens the protein homeostasis and might cause actually the aggregation and the neurodegeneration. So you can link many processes we see in aging, you can causally link it back to DNA damage.
I see.
As a trigger.
I see. I have a question that I agree with you that genome is very important, but the Werner syndrome or Hutchinson-Gilbert syndrome, it's an exaggeration. For example, the calorie. If you don't eat anything, you die.
Yes.
But the certain restriction is beneficial.
Correct.
So like Werner or the Hutchinson-Gilbert is exaggeration. Exaggeration is bad, but a certain damage should be okay. There's a discussion about that. How do you argue about that?
So for the calorie restriction, I think it's the universal intervention that is working from yeast all the way to mammals. Right. So definitely it works, but what's important is that it's a very narrow optimum, and defining this optimum is very complicated. You can take the simplest organism, and calorie restriction will extend the lifespan, but if you drive it a little bit too far, you get detrimental consequences.
Right.
Malnutrition is the most dangerous thing. So, and for humans, it's much more difficult to find the individual optimum, because every person will have a slightly different optimum. And defining that requires that we can measure the outcome of calorie restriction. The next step of that will anyway be pharmacological interventions. Now the first trials will be done with metformin. There are new developments on rapamycin and related. Yeah. So because calorie restriction as such will not be applicable to a broad population, because people just won't adhere to diets. So we need to have these pharmacological interventions, but then we need to have biomarkers to measure the outcome.
I see.
And that's a development that's very, very important, and it's not there yet.
And you think a biomarker can be related to the genome stability? Because from my point of view, genome stability is far from the clinical application. Considering the calorie restriction. Calorie restriction is easier than let's stabilize our genome. I think, how do I do it?
So it's genome stability is much more complex.
Yeah.
Because there are many different, there are thousands of different types of DNA lesions, so it's very complex. As a biomarker, it's complicated because it's so difficult to measure. The biomarker that comes closest to genome stability is telomere length.
Right.
But even that is very difficult to assess because we know now it's much more important how critically shortened the one telomeres are not the average of a whole cell.
Recently, I checked my telomere length. It was 68 years old. It's the longer than me, so I'm very embarrassed. I'm exercising, I'm sleeping well, but how do you evaluate the telomere length?
It's much more complex than people initially thought because what is measured is lymphocyte telomere length, and so there is a correlation, but the correlation is not very strong. So it's not good enough. Telomere length is not good enough as a biomarker. Instead, there are, for example, epigenetic markers that seem to have a much higher predictive power.
Is that right? But the people think the telomere length longer the better. And I think it makes sense to consider such way.
That's correct, but there is an association between telomere length. The longer you will live. But again, it's a weak correlation. But also there are ideas of using therapeutically lengthening of telomeres, which of course is dangerous because cancer cells use long telomeres to survive. So it's not that.
So there is several supplements that extend the telomere length. How do you evaluate these supplements which extend?
Well, I think what's really important is that what we need is human studies. We need human trials, and that's very complicated to do. Nobody will do this based on supplements because it's just too expensive.
I see.
For example, we have some evidence that metformin might have beneficial.
I'm taking metformin, by the way. Are you taking?
No, I'm not taking it. But the problem with that is that nobody will pay for the clinical trials.
Yeah, but now it's under the way.
It's underway,
in
but
the United States.
But and it's very costly, and we need to find different ways of assessing anti-aging medicine. We cannot do it with the traditional system of clinical trials. We need to change that.
Okay. As a biomarker, you have mentioned about not the telomere length, but do you think methylation of the DNA is more sensitive to the aging process?
That has been recently found, indeed, that methylation patterns have a good correlation. What is not clear yet is whether they are responding to interventions like calorie restriction. So that's the limitation at the moment. We don't know what they mean because they're not associated with genes. And second, we don't know whether they will respond sufficiently to interventions because we know that calorie restriction, for example, works. So we would expect that they respond to that, and only then will they be good biomarkers.
So going back to your work, that you have given us a wonderful lecture today. And DNA repair is a very important two system we have. One is repair as soon as possible, where the DNA damage tolerance is increased. Okay. So the other audience for this anti-aging medicine, we interested in clinical application. So your that is any clinical application?
Yeah, I think we have a lot of clinical applications because on the one side we understand now better the importance of signaling mechanisms that promote longevity. And here, for example, we know that insulin-like signaling plays a major role. There are many inhibitors that are already clinically evaluated that interfere there, that could potentially be used.
Yes.
With the concept of increasing DNA damage tolerance, I think there's a clear path of doing this. For the DNA repair itself, it's a bit more complicated. There are examples. I mean, one example of how to directly increase DNA repair is an enzyme that can be used in the skin. It's called photolyase, which directly repairs UV lesions. Humans don't have it. That's why we are susceptible to skin cancer. But this, for example, is an example of a simple repair mechanisms that can be directly used to enhance DNA repair. for many of the repair systems, it's at the moment too complex, but that doesn't mean that in the future we can really address the bottom line problem of both cancer and aging, which is DNA damage.
Okay, from your point of view, the UV is a bad guy. So, but of course, for the skin cancer, UV is bad. But there are a lot of, the epidemiological study that the sunlight is beneficial. For example, increase the vitamin D level or prevention of the depression. So, how do you think about sunlight exposure?
So sunlight, it is important for the human to be exposed to sunlight, but it's important to protect from the UV. And it's very easy to protect from UV because you have skin lotion and many possibilities to do that. So I think it's important to protect from UV and at the same time get the beneficial effects of sunlight.
I totally agree. From the point of blue light and violet light, we need a blue light and violet light, but we don't need a UV.
Yeah,
we
UV
need
is very dangerous.
we need some amount for the vitamin D production, but not so many. Okay. Thank you very much. So at last, do you have some recommendation to the audience of journal that something you do for your anti-aging?
Yeah, it's very important to do the things that we know that work, and that is healthy lifestyle. We know that two-thirds it's environmental factors that determine how we age and how we get sick with aging. So we have a lot in our hands.
But 30% is a genome, you mean?
30% is genetics, but at least we are born with the genes we have, so we can do a lot with that. And what's really important is to eat healthy.
Eat healthy, number one.
And to do sports.
Then second is sports.
It's only the combination that works. You cannot do one without the other.
Okay.
It has to be the combination.
Okay, so
and it works for everybody, whether you're young or old. It works for everybody.
Thank you. Every time I listen to these important words, I determine myself again. So, Dr. Schumacher, thank you very much today.
Pleasure.
Thank you.